This is the second proof that I teach with regards to how to manipulate complex numbers in polar form. We're going to start with two numbers that are in polar form that are expressed in a fraction, or we're dividing one by another one. Now, we need to remember all the way back to the first series about what we need to do when we have to rationalize the denominator of a complex number. So, if I expand out this, I know that whenever I have a complex number with an I in the denominator, I need to multiply by the conjugate. So you see there's a change in sign here. Oopsies, I've lost the cos there. So now I'm going to expand this out. I'm going to start with the numerator and then I'm going to do the denominator. Now this here would give me cos alpha cos beta minus, I'm going to put the I in front always, I times by cos alpha sine beta plus I sine alpha cos beta minus, I times I, remember, is minus 1, and I have a minus, so it's a double minus, so it's plus sine alpha sine beta. Okay. Now we're going to tidy that up on the next line, but let's have a look at what happens on the denominator when we're multiplying out the denominator. Here we're going to have cos squared beta minus I cos beta sine beta plus I sine beta cos beta, and then that's going to be plus sine squared beta. Remember, when we multiply by a complex number by its conjugate, all the imaginary parts cancel out. So let's loop back to the top and see what we have going on here. I told you this in a previous proof, but it's just really good to remember you always need to organize with reals and reals and imaginaries and imaginaries. And that's going to be my first step here. So these guys are going to go together. Okay, then we're going to factor out the I. And then these two are going to be the imaginary parts. So I'm going to have sine alpha cos beta minus cos alpha sine beta. On the bottom, or on the denominator I should say, we have cos squared plus sine squared, which is our Pythagorean identity, so that's going to be just 1. Now, if you were watching the previous video, you'll remember there is a link here with these identities to the compound angle formula. In fact, this is the compound angle formula for cos alpha minus beta plus I sine alpha minus beta. And if you're not sure how I got from here to here, make sure to watch my video on the compound angle identities. And that, oh, I have actually lost my r's. So this was r1 divided by r2, r1 divided by r2. So we're going to pull those up front. And we can summarize as follows, that r1 cos alpha plus I sine alpha divided by r2 cos beta at I sine beta ends up being equal to r1 divided by r2, so you need to divide the moduluses, and then cos of alpha minus beta at I sine alpha minus beta. And now this is in fact in polar form. If you want to stick around for the next example, I'm going to put some numbers in the mix so you can see practically how you can apply this proof, this formula, to a situation that you might get in your A-level or IB exams. So that's all coming up in the next video. I hope you guys enjoyed the proof. Like, comment, subscribe. I love reading all your comments. See you in the next one, guys. Bye for now.